So this is constant acceleration quiz practice part 1. This is a position time graph similar to what you've seen in worksheet 1. And this line is showing us that it is no longer a constant velocity. The velocity is now changing, and this black line is showing that what we learned in Unit 2, the velocity was constant. And now this pink line that I'm drawing is showing that the velocity is not constant. And here the velocity is changing, and it looks like it's also increasing. And I'll show you in a moment how we know that the velocity is increasing. So here for number 1, we will describe the motion as the object is speeding up in the positive direction. And we know that it's moving in the positive direction because it starts at 0 and it keeps going away from 0 as time is increasing. And these blue lines that I'm drawing are the tangent lines. So at each time, we see that these tangent lines keep increasing in slope. So they're getting steeper, which shows us that the object is speeding up. And now, number 2, we're going to find the average velocity of the motion of the object from time 0 seconds to time 10 seconds, and we're going to show our work. So the average velocity, as you know, is just the final position minus initial position over final time minus initial time. We're going to use 10, 278 as our final point, and our initial point is 0, 8, which I've highlighted here for you. So the final position was 278 minus the initial position of 8 over final time of 10 minus 0 seconds, and we're going to get 270 over 10, which will give us an average velocity of 27 meters per second. And now we're going to describe 2 ways that you can find the instantaneous velocity at 7 seconds. So one, we can find it using finding the slope at 7 seconds, but most of you in algebra probably haven't done it yet. So what we're going to do is use the average velocity using 7 as the mid time. And so we'll pick a time before 7 and after 7. So we'll pick 6 seconds and 8 seconds. And we'll just do the same thing we did in number 2, finding the average velocity between 6 and 8 seconds. And that will be parallel to the tangent line that we've talked about in class. And so we have 184 minus 110 over 8 minus 6 is going to give us 74 over 2, which will result in 37 meters per second as our instantaneous velocity at 7 seconds. And we'll just do this the same thing using different initial and final velocities for time, different sets of time, right? So since we've done 6 as before and 8 after, let's try using 4 as our before and 10 as our after. And 7 will still be right in the middle of 4 and 10. So we have 278 meters minus 56 meters over 10 seconds minus 4 seconds. So 278 minus 56 is going to give us 222 meters over 10 seconds minus 4 seconds, which is 6. And this should also equal 37 meters per second. Hopefully you're following along with your calculator, making sure that my math is right. So both average velocities, even though we pick different points, should be the same because we're following 7 as our midtime, which is different from the average velocity of the whole object. All right, that's it.